right, guys, just kind of reviewing what a logarithm is and how you switch back and forth from exponential to log form. This isn't even really in the notes, but I saw that a lot of people in the other class didn't understand that, how you go back and forth between an exponential and a log. So let's say that I have 3 squared equals 9. Okay, that's a true statement. If I want to write that as a log, it's going to be log, find the base, there's the base, come around to this, and back around. So log base 3 of 9 is 2. That's a true statement. If I wanted to evaluate log base 3 of 9 to check that I'm doing this correctly, I can go under math, I can go up to log base, and I want log base 3 of 9. And it tells me the answer is 2. So I know that I rewrote that correctly. Sometimes people think, well, why couldn't you do it like this? What about log base 9 of 3? What if I put log base 9 of 3? Would that be 2? No, that's not going to work. Okay? So you guys try this one now. So what if I gave you 7 squared equals 49? Write it in log form. Haley, what do you think? Right. Okay. So what if we have to evaluate a log now? So let's say that we've got log base 5 of 125 that we want to evaluate. Well, I just say, okay, this is going to equal something. I can call it x. So now I'm going to go in the other direction. Look what the pattern is. To go back to this, I find my base, I go to the 2, and then back to the 9. It's always swirling it around. On this one, I start with the 7, 7 to the second power, swirl it back around is 49. So to solve this, it's 5, go across, swirl back around. So what's that answer? 5 to the what is 125, guys? 3. So the answer to that is 3. Okay? So that little background there should help us with this. So log 1. You have to know that anytime you don't see a base, the base is automatically 10. So what this would mean is 10 to some power, or 10 to the x, has to equal 1. What's the answer to this then? 10 to what power would be 1? 0. This answer is 0. Log 1 is just 0. In fact, the natural log of of 1, the natural log of 1 is also going to be 0. Do you remember what the base is of natural log? If you don't see a base on natural log, you'll never see a base because it's always assumed to be, 2.72 about. It's e. It's that number e. So anytime you see natural log of 1, you have to know that's 0, and log of 1, that's also going to be 0. These are some properties you need to know. Is log of a times b is log a plus log b. If I have log a to the n comes down in front. It's n log a. If we have division, that turns into the subtraction of 2 logs. These are some special properties that are helpful. Think about this. Log base 2 of 2, log base 5 of 5, log base 10 of 10. What would that answer always be? It'd be 1, wouldn't it? A to the what equals a? 1. What about this? Log 10. What's the base? The base is 10. So 10 to the what is 10? 1. That's 1 as well. I already told you this one. If we see natural log, the base is e. E to the what is e? 1 again. All right. These kind of questions are things we always come across. It says, given that the natural log of 2 is approximately 0.6931 and the natural log of 3 is approximately 1.0986, find the following. The natural log of 18. Well, I want to rewrite this using these numbers that I know. I know 2 and I know 3. So 18 I can think of as 9 times 2. But 9 is 3 times 3 times 2. See that? How 3 times 3 times 2 would be another name for 18? And then what did we say multiplication turns into for natural logs? Addition. So it's going to be the natural log of 3 plus the natural log of 3 plus the natural log of 2. So to figure this out, I can go to my calculator, and I know the natural log of 3. It's 1.0986 plus another one of those plus the natural log of 2. And I get 2.8903. All right, what about the natural log of 2 square root of 2? How can I write that? Natural log of 2 to the 1/2, right? If I have it to the 1/2 power, it can come out in front. So it's 1/2 times the natural log of 2. So to do that, I do 1/2 times the natural log of 2. I already was given that. It's right there. 0.6931, and I get 0.3466. Questions so far? All right, what about 0.3 repeating? How would we rewrite 0.3 repeating? You might know another name for 0.3333? 1/3, right? So 1 divided by 3. What do we change division to? Subtraction. So I'm going to have the natural log of 1 minus the natural log of 3. The natural log of 1 is one of those special properties. Look up here. The log of 1 and the natural log of 1. It's 0. So I have to recognize that this is 0 minus, and looking up here at the natural log of 3, I don't need a calculator for that, obviously, negative 1.0986. Guys, can you see how that really makes sense? Because if I have the natural log of 1/3, couldn't I also write that as the natural log of 3 to the negative 1? And so then the negative 1 could come out in front. So it would be negative whatever the natural log of 3 is. See how it works no matter how we write it? Okay, letter D. Natural log 0.25. What's that as a fraction? 1/4. So I'm going to have 1/4 to the 1/3 power. Cube root means to the 1/3 power. So I want to pull the 1/3 down in front. And I'm going to have 1/3 the natural log of 1 divided by 4. So that's going to be 1/3 the natural log of 1. And then I got to think of 4 as being 2 squared. I can think of it as 2 squared. So I'm going to have the natural log of 1 minus the natural log of 2 squared. But if I have that 2 squared, I can bring that 2 down in front. So now I have 1/3. And then what's the natural log of 1 again? 0. So I'm really going to have 1/3 times negative 2 natural log of 2. So I'm going to have 1/3 times negative 2 times the natural log of 2 is right there. And we get negative 0.4621. All right, let's go down to the next section. Using properties to expand the log expression. The reason we have to be able to do this is it's going to make our derivatives and integrals of these a lot easier. That's the last kind of thing we're going to do in calculus this year, is take derivatives and integrals of logs and exponentials. So in order to be able to do this, we have to be able to expand. So if we have multiplication, that's going to turn into addition. So this could be log 3 plus log x squared. If I have an x squared, though, I can bring that 2 right here in front of this log. So log 3 plus 2 log x. That would be that value expanded. Notice on this one, it's only the x that's getting squared, so the 2 only goes in front of this term. Whereas on this one, it's the whole thing that's getting squared, so the 2 has to go in front of everything here. So the first thing I'm going to do on this is bring the 2 down in front, whereas here I could not bring the 2 down in front because it was only with the x. But this one I'm going to start off by doing this. And so now I'm going to have 2 natural log of x squared plus 3. And this 2 goes with the whole thing, so I have to put parentheses here to show that it's the 2 goes with both. It goes with the top, and then minus. And then if I have natural log of x to the 4th, that's 4 natural log of x. And that would be the expansion there. If I was checking this, I would check to make sure that you had the 2 in front with parentheses around the whole thing. So sometimes we do derivatives and integrals, and we end up with something like this, and it's not what the back of the book has, because they simplify it down to a single value. So to take this one down to a single value, I can see here that I've got the natural log. This is addition, so I'm going to be multiplying these. This is subtraction, so that's going to go on the bottom. When we simplify, we take a bunch of logs and turn them into just one log. What else is happening to all of this? It's getting raised to the third root, or third power rather. Notice it's not the natural log that's getting raised to the third. It's only these x things that are getting raised to the third. All right, this one's kind of similar. Think about it. So we have log. Where does the x go, guys? On top or bottom? Goes on top, doesn't it? This is subtraction. So where does the x plus 3 go? On the bottom. And then where does the x plus 5 go? On the bottom. All right, now what are we going to do with all of this stuff, though? It's all getting raised to the third. And notice that I didn't put it on the outside. It's only this that's getting raised to the third. Because now, if I were to change it, the 3 would come out in front, and it would become like that. All right, any questions? Okay, so you guys have just a couple of problems to do. You're going to have page 321, 7 through 10, 17 through 33. You can do every other odd. I want you to get that finished, show it to me, and then we have one more thing to do with the derivatives.